This is Mrs. Carnes, and this video is going to show you an example of how you would solve an inequality. The reason it's very important to know how to solve an inequality is because we will use real-world examples and they will be modeled by inequalities when an equation is just not suitable for it. Very first thing you want to remember is you already know what an inequality is. There's 4 different symbols for inequalities. There is greater than, is less than, is greater than or equal to, and is less than or equal to. So let's take a look at an example that involves these inequalities. Before we begin, we want to remind ourselves of actually how we would solve an inequality. The very first thing that you want to remember is we're going to start solving an inequality just like we would solve an equation. We're going to use inverse operations. We're going to look for parentheses because that would tell us to use the distribution property. If we see like terms, we're going to make sure that we combine them. We're going to try and get the variable by itself on one side of that inequality symbol so that we can find the solution, just like when we're solving equations. So we're going to start off the process very similar to how you would start solving an equation. You also want to remember that inequalities will have an infinite number of solutions, and this differs slightly from equations because remember, equations don't always have an infinite number of solutions. In fact, most of the time they don't have an infinite number of solutions. The most important thing to remember about inequalities is this next statement. This is basically a rule that you're going to have memorized and remember when you're dealing with an inequality. When you have an inequality, the inequality symbol will flip directions when you multiply or divide by a negative number. So when it starts off, you're going to continue on, and whenever you multiply or divide in the process of solving by a negative number, you're going to actually have to flip that inequality sign. We'll take a look at what this looks like in the example that follows, but it's probably the most important thing that you can get from this video today because it's how it differs from equations. Finally, when you go to check your solution, it's going to take a little bit of a different process. You're going to actually have to check 2 different cases because remember, solutions to inequalities have infinite number of solutions, and so we're going to have to look at that process a little different when we go to check, and we'll take a look at that also. So let's go ahead and look at this example. The example is 2 times the quantity t plus 2 minus 3t is greater than or equal to -1. Now we see the inequality here, so we know that we're dealing with an inequality rather than an equation. But we're going to start off the same way. We see parentheses. We know that that 2 must get distributed through the parentheses since it's multiplication. That leaves us with the inequality 2t plus 4 minus 3t is greater than or equal to -1. Now notice the inequality symbol has not flipped directions. We did not multiply or divide by a negative, so it stays exactly the way it is. We now notice that we have like terms. We see a 2t and a minus 3t, and we have to combine those together. When we combine these terms together, we end up with a -1, or just a negative t plus 4. Is greater than or equal to -1. And again, notice that the inequality symbol has not changed directions. All we did was combine like terms, so the inequality symbol stays the same. Now this inequality should look very similar to an equation that you've done before. You know you need to get the t by itself, so the very first thing that you need to do is get rid of that positive 4. Using your inverse operations, we subtract 4 from both sides, and we're left with -t is greater than or equal to -5. Again, we subtracted a 4. We did not multiply by a negative. We did not divide by a negative, so the inequality symbol stays the same direction. Now this last step we take a look at, we know that the t is still not by itself. It has a negative in front of it. More specifically, it has a -1 in front of it. And to get rid of that negative, we have to divide both sides by the -1 to get rid of it. When we do, we end up with a t. Now, if you're careful, bells and whistles should be going off in your head as you do these problems because this now tells me, wait a minute, I divided by a negative, and that tells us that we have to flip our inequality symbol. And then we simplify -5 divided by -1 is +5, and that would be our solution to this inequality. Now before we move on, let's take a look at that last step one more time. In this step here, we divided both sides by the -1 in order to get rid of the negative, so t would be by itself. And when we divide by a negative, we know that we must flip the inequality sign, so that sign became a less than or equal to from a greater than or equal to. And so this becomes our solution. Now that only happens when you multiply or divide by a negative number. Had we multiplied or divided by a positive number, then this inequality symbol would have just stayed greater than or equal to. Please do not get it into your head that every time you have an inequality it must flip. It only flips if you multiply or divide by a negative number. That's what the rule says. So let's take a look at how we would check this solution. So we know that our solution is t is less than or equal to +5. And so when it's an inequality, you actually have to check two different things. The very first thing you want to check is t equals 5, because we want to check to make sure that our actual calculations were right here. We want to make sure that the math that we did to solve this was correct. Our distribution, our combining like terms, our inverse operations. So we would plug in 5 into our equation, or I'm sorry, into our inequality to see if it equals. So we're going to turn this kind of into an equation to see if this works. So 2, and then we plug in our 5, minus 3 times 5, rather, is equal to -1, and that's what we want to check. When we check this, 5 plus 2 is 7, 7 times 2 is 14, and 3 times 5 is 15, and 14 minus 15 is equal to -1. So we know that our computation was correct. We did the math correct, so that takes care of that. Now we need to take a look at the second part of our checking our solution, which is t less than 5? Is the direction of our inequality going to be correct? So let's take a look at some value that is less than 5. Now here you want to be smart. You want to choose a value that's going to help you and make the inequality easy to simplify. So we could choose 4, we could choose 3, we could even choose 1, which would actually be very helpful, but 0 would be the easiest value of t. Because 0 is less than 5, I can plug 0 in, and I would get the inequality to look like 2, 0 plus 2, minus 3 times 0 is greater than or equal to -1, and that's what we want to check. And when we simplify this, this becomes 2 rather. 0 plus 2 is 2. 2 times 2 is 4. And 3 times 0 is 0. And when we subtract 0 from 4, we want to check, is it greater than or equal to -1? So is 4 greater than or equal to -1? And we would say yes, it is. So now you've seen an example, and a pretty complicated example that had a lot of steps of solving an inequality. So go ahead and try a few on your own, and then you'll probably start to see some real-world situations that will use inequalities, and you'll be able to use these same steps to solve those problems.